when we talk about converting a liquid-filled transformer to a dry type specification, what has to be done in order for us to accomplish that? And again, what we're trying to say is that the basic operation of liquid and dry type transformers, it's the same. A lot of times we're changing voltage, we're providing, possibly some harmonic mitigation depending on how the phases are arranged. We might be obviously providing short circuit mitigation, stuff like that. But the thing to remember is we're kind of comparing helicopters and airplanes. They both fly, they both do the same job. They might both be able to do the same job effectively, but we just need to make sure that we're specifying the stuff correctly. And again, one of the keys we have here is that when somebody calls and says, hey, I have a liquid filled transformer, can you give me the dry type equivalent? We can't. That is not possible. Okay, there will be a whole bunch of exceptions. And the best way, if you want to consider a dry type alternative, is to come up with a dry type specification that best meets the needs for your application, knowing that oftentimes you may also have to address site installation in order to get the true advantage of either design. So dry type transformers. Right now we're looking at applications below 44 kV. The BIL, which is the basic impulse level, the highest voltage level that transformer can get hit by a not arc, we're looking at 250,000 volts, 250 kV. For dry type. Typically, dry type transformers will be 40 MVA and below. That's a pretty big transformer. But when we start talking about 100 MVA, main power transformers, typically high voltage units, those are really the domain of liquid filled transformers. Pole mounted units, we already addressed that earlier in our conversations. And if there's areas that are accessible to the general public, liquid filled transformers often have some advantages. As an example, behind our house in our subdivision here, we have a little green transformer case. It's liquid filled. It's about the size of half of an oven. It's only about 2.5 feet tall. Kids go climbing on it. That is a hermetically sealed unit. And I don't like the kids climbing on it. In fact, I take them off. They shouldn't be. But a completely ventilated unit probably is not a good idea to install in an application like that. That's, again, so it has a lot of accessibility to the general public. So when we look at a specification for liquid filled, sometimes the transformer specification doesn't actually say liquid filled, or sometimes it does, but you have to kind of get into it. There are some clues, though, that will key us into liquid filled. When we hear the words bushing wells, anything that says bushing, anything that says drain plug or fill plug, again, these are typically associated with liquid filled units. That will tell us it's a liquid filled transformer specification. Manual load break switches are, again, something that's more common within the transformers. There's certain things that I can do with a switch that's also surrounded by the oil that the transformer is using that I can't do as easily if it is a what we call an air switch, a normal switch that operates in the air versus something that is submerged in oil. Obviously, things like liquid level gauge, pressure gauges, these all indicate that I'm using some type of a liquid. Valves. FM Global Approved is a insurance agency that does a lot of stuff with commercial properties, especially in North America. They tend to have certain specifications for liquid filled transformers. So having something that might meet their overall specifications will help standardize what the insurance policy is for that area. We will see certain IEEE standards that are specific to liquid filled versus dry type. Again, we might see things like dielectric coolant, less flammable fluid, under oil or oil immersed. All of these terms and conditions are really reflective of a liquid filled transformer. And by the way, there is no dry type equivalent. So when somebody, again, hands us an oil spec, we can't meet this. Probably don't need them, but again, can't meet it. So there's a couple things. We sometimes run into a situation where a specification says no load tap changers. This is where you can install a relatively simple mechanical tap changer in the actual oil that the transformer itself is submerged in. And by twisting a dial with a wrench or something like that, I can change the taps within the liquid. And there's some advantages to doing this. I can do this relatively inexpensively and easily because I'm not worried about arcing where I would be if the switch was just in air. And I also don't have to pull all those taps out with additional bushings through the transformer. So there's less points where that transformer can leak. Okay, this is not a bad solution for a liquid filled transformer. With a dry type, we don't need a rotary tap changer. It's a no load tap changer. Well, if the transformer is under a low load, it's a dry type, I simply go and physically remove the bolts on the taps and change them. So when some people say I want a no load tap changer, that's because I have a problem bringing additional wires through the transformer sidewall and potential for leaks that I don't want to encounter. And I can fix that. I can mitigate that by having a no load tap changer submerged in the oil. I don't need to do it with a dry type. Okay, and we sometimes have people say, well, I still want the no load tap changer. Well, in order for us to put contactors in that can do that, becomes a very complex and expensive means to do for a dry type transformer. Again, we would just say change the taps. By its nature, liquid filled transformers are sealed in a non-accessible, non-ventilated enclosure. Dry type transformers, by their very nature, are ventilated. And again, those ventilation holes provide us with some concerns that the transformer is accessible to the general public. Efficiency, there are different efficiency levels for liquid filled versus dry type. The efficiency levels generally for a liquid filled, actually not generally, always for liquid filled, will be a little bit better, a little bit higher efficiency levels than the dry type. And we've addressed that earlier. Terminations, liquid filled have fewer options for terminations. Again, generally you have a front mounted wiring compartment, and all terminations have to be within certain locations in that small wiring compartment. With a dry type transformer, you have much larger ability to bring in stuff from below, from the roof, from the sides than you do with the liquid filled. So again, a lot more flexible in the cabling and busing methods for a dry type. Temperature rises we already addressed. We have a lot of additional temperature rise options and overload options for dry type. As a result, the kVA sizes for dry type and liquid filled may not necessarily match. I may be able to do something, with 1,000 kVA dry type transformer, 115 degree C temperature rise, which is a low temperature rise transformer, that maybe somebody specified in a 1,200 kVA liquid filled because they didn't have that low temperature rise flexibility, or as much of that flexibility with a dry type transformer. Dead front construction is very typical with liquid filled. Oftentimes it might be part of a larger utility requirement, which has to, which could be very important within the installation of that transformer. Dry type transformers can be built with a dead front construction. It's not as typical as it is with liquid fill. We have done it, we do it all the time. But again, it's something that is a little bit different. And you have to be careful when you say dead front construction. Typically what you do with a dry type is the way we would interpret that is we bring all the connection points into a separate terminal, often called an air terminal chamber. And then we have a dead front construction on that specific air terminal chamber. However, there are additional access points to the main transformer, and those are typically open because we would have some difficulty in blocking those off with some type of a dead front construction for the cooling characteristics. Again, you can do it, but it's not really the way most people would. Sound levels, again, liquid filled will be a little bit quieter than dry type by the very nature that the corn coil is submerged in the liquid, and that helps deaden the sound. You can do lower audible noise transformers with dry type, but they tend to cost a little bit more, be a little bit bigger. However, because liquid filled transformers don't have all of the temperature rise options that dry type do, oftentimes with liquid filled, you might be more common to employ cooling fans, which can greatly increase the dB level of that particular transformer. There's different terms. Liquid filled has ONAN, ONAF, OF, AF, OF, WF. Those aren't directly attributable to the terminology that we use for dry type transformers. So, if we see an onan, we don't necessarily have a direct equivalent. I guess the closest one for us would probably be ANN, but again, different terms, and in some cases different methods to do the cooling. I'm not going to go into all of these, but again, just be aware when we see these cooling terms that start with an O on the left-hand side of this chart, we know pretty much that this was a liquid-filled specification. A lot of times you run into questions on the insulation system, and by their very nature, liquid-filled transformers run cooler, and they have to run cooler because of the insulation system that they use. And they have some, methods to cool themselves differently than a dry-type transformer does. However, the insulation systems for a dry-type transformer are much, much more robust. So really, when we talk about, the temperature rise, what temperature that transformer runs at, you do not need to have an equivalent, very ultra-low temperature rise for the dry-type. The insulation system can handle much higher transformers and still give you easily the equivalent lifetime of use that an oil does. So, we do have to change and make sure that the temperature rise requests are equivalent. Otherwise, we will be building a much, much lower temperature rise transformer with a dry type than is probably needed, and the cost and size will escalate accordingly. So again, we've had some other graphs here in the temperature rise options. You can see here that depending on the temperature rise, an 80°C temperature rise transformer, which is a common option in dry type, can actually handle an ambient temperature hotter than the boiling point of water. You don't have those options with a liquid-filled transformer. So depending on what ambient temperature you're going to run that transformer at, I can either run it at higher ambient temperatures or I can get some additional capacity. When we look at the additional capacity, you can see that that's at a 30°C average ambient versus the column just to the left of that, which has higher average ambience. So again, a lot of additional temperature rise options with dry type that can affect the design protocols and the equivalent kVA that you would be specifying and using. Site preparation is a big one. With liquid-filled transformers, there might be things like spill containment, fire suppression, drainage, environmental assessments and additional permitting, transformer vaults, limited busing and connection vectors that will result in some differences in design that may not be any consideration or any issue for a dry type. If you want to get the best value out of a dry type versus a liquid filled, you really have to compare the application, and you have to come up with a dry type specification and site preparation work specific to that dry type transformer to get the true value out of it. If you're looking just at the cost of the two transformers and not including some of these additional preparation costs, a lot of times it'd be more favorable to a liquid filled transformer. When you take these other issues in consideration, that would adjust a lot of times where your cost and benefit analysis would bring you. So final notes. We do have, Hammond does build a lot of medium voltage transformers. We believe we are the largest medium voltage transformer manufacturer in North America, one of the largest in the world. We do have both a VPI, Millennium series, and a cast coil, our EnduraCast coil for the North American markets. So we can supply transformers. And when you look at the voltages and the max kVAs that I've given earlier in these presentations, those would be equivalent to what our maximum kVAs would be as well, and voltages and BIL levels. Other manufacturers that build this may have much lower capabilities. Our biggest thing here is that if you do want to consider a dry type transformer for what we would normally, maybe in the past have specified a liquid filled for, there's a lot of different design considerations you have to make to get the true advantage. In a lot of cases, there's some great advantages to liquid filled, and there's some applications that, there's some great advantages, to liquid filled, there's some great advantages to dry type. We would like to, if you have questions, you can call us. We're more happy to work with you. We will try and give you a halfway decent assessment. Where we have often issues with is when somebody just gives us a liquid filled transformer specification, says, give me a dry type equivalent. Oftentimes we have to reject those because we simply can't. That doesn't exist in a practical sense. And again, the goal here is to make sure everybody has an appreciation for that. And if you do want to approach that, how do you approach that problem effectively to get the full value for you? Well, I'd just like to thank Sumant. I would like to thank all of the attendees for spending some time. Hopefully you found this training valuable. If anybody has any questions, please don't hesitate to contact our sales or marketing group. We'd be more happy to talk to you. And we wish everybody a wonderful day. And again, thank you so much for your time and considering Hammond Power Solutions. Bye, everybody.